Hello everyone, this is video 1-10, Unit 1, 10th video, 10th day of the unit, and it should be watched on Wednesday, 9/21. The following techniques are used to find limits when direct substitution does not work. Okay, so we talked about in the last video how you could use direct substitution if the function is continuous at the x value you are approaching. But if it's not continuous at the x value you are approaching, when we started out with limits, I would ask you to draw like an arrow diagram. Think about it from the left, think about it from the right. But that's important, I think, for really wrapping your head around what a limit is. But in the future, instead of going like to an arrow diagram, we're going to try some other things first, okay? So I would say doing an arrow diagram and thinking about approaching from the left and right, that should be like your last resort when you're trying to wrap your head around a limit. Direct substitution, try that first. If that doesn't work, you're going to want to try the things that I talk about today, okay? There are 3 examples in this video lesson, but we're only going to do the first 2. I'm going to do the third one with you in class, okay? So, example number 1. Here's a situation where direct substitution will not work. You cannot plug -4 in for this function because this function is undefined at -4. It's not continuous there. Being defined at a value is the first criteria of continuity, and this is not continuous at the x value that we are approaching. So in this case, guys, what you want to do is try to manipulate the function to view it in another form. And the first way of manipulating it that I'm going to cover is factoring. Factor and see if anything cancels. So to do this, I'm going to go off to the side, all right? So go off to a margin or something and just consider the function on its own without thinking of the limit. So I'm just going to consider this function. I'm in a margin, okay? So can I factor the numerator? Absolutely I can. X, they've got to multiply to make -4 and add to make 3, the 2 numbers I'm thinking of. So +4 and -1. And then those are going to cancel. So now that I have taken my expression and I have rewritten it as an equivalent expression that doesn't give me a problem, like when I plug in -4, I'm going to go back up to the beginning. And as long as you have this work shown like in a margin, then you could jump right to the next line, which would be the limit as x approaches -4. So this limit is equivalent to the limit of that function. All right, if you want to put parentheses there, you can. And now, can I direct substitute into this function? Absolutely. So this is -4 minus 1, so -5. All right. Now, guys, a lot of my students in the past have been confused about the limit notation, like when can I drop the limit? You can drop the limit once you have the answer. Okay, so once I direct substitute, that is the point at which I'm actually like computing the limit. So that's why I don't say this anymore. I hope that was clear. If it wasn't, let's talk about it in class or come see me, okay? But the notation is very important. Okay, so there's that. Now, the second example, so the first thing you want to do is try to direct substitute when you're taking a limit from now on. So the limit as x approaches 0 of this function, I can't just plug in 0 because I end up with 0 in the denominator. So this function is not defined at the value we're approaching. So it's not continuous there, so I can't direct substitute. But what I can do is I can go off to like a margin of my paper and, you know, don't think about the limit for a minute. Just think about the function you're working with and ask yourself, can I rewrite it? And yes, we can. We can expand it. Okay, by expand, I mean actually multiply this out. So this is 5 plus x times 5 plus x minus 25 over 2x. All right, so I'm going to keep going. So what we want is for this x to cancel. Okay, if it does, then we can direct substitute. So I'm, double distributing, or however you think of it. This is 25 plus 10x plus x squared minus 25 over 2x. Those are canceling. This is equal to, I'm factoring out an x. Okay, so I just have this now, but I can see right away that I can factor out an x, and then left inside I will have 10 plus x over 2x. Perfect. All right, that's what we want to happen, guys. All right, so now I can go back up here. I already have all this shown for my reader, so they're not going to be confused when I jump from the limit as x approaches 0 of this to the limit as x approaches 0 of 10 plus x. Now this is a function I can direct substitute into because I won't end up with 0 in the denominator. So this is just 10. Perfect. Okay, so now I'm thinking about your homework. Ooh, I messed up. This is over 2. Sorry, that's over 2. So when you direct substitute, that should be 10 over 2. So the answer is 5. All right, so that's the answer right there. Okay, so now I'm thinking about your homework. That was another short video. So the homework is going to be page 21, the entire thing. Okay, so page 21, all. All right, I'll see you tomorrow. Email me if you have any questions or trouble with the homework. Okay, bye-bye.